Yeah, hooray! I think I fixed it. I fixed the problem. So let's talk about the marine dilemma. So what's the problem? Okay. The problem is that in the euphotic zone, you typically have a nutrient limitation. Not enough nutrients because of gravity or negative buoyancy, inducing this gravitational settling of particles. Okay, so you have very, very low nitrate conditions and surface waters, and that's shown in this little sketch. Here you can see from the surface to about 60 meters or so the distribution of nitrate, and nitrate is this line here. Let's see, I have to activate the mouse. You can see the mouse from the very, very low down to something like 25 meters here, and then it increases. Okay, so it's already shown a mechanism that actually now can induce a phytoplankton bloom through what we call entrainment. Entrainment means mixing in of nitrate. It's a one-way mechanism. You actually mix in the nitrate. Okay, so you have a surface mixed layer which has a warm surface mixed layer with a high temperature. Okay, this is the base of the surface mixed layer. And now in these examples, and indeed at depth you have a light limitation. So at depth you can't produce much or at all because you don't have enough light. And instead what you often get is you get actually phytoplankton production in a zone where you have enough nutrients and where you have enough lights. And this is the transition zone here. At the base of the surface mixed layer, you can see a chlorophyll maximum and primary reproduction also. They're not necessarily on exactly the same spot or so. Okay? So this explains a little bit the marine dilemma of low production in many regions, unless you have a physical mechanism. So what are the physical mechanisms? We don't come to that yet, but we just illustrate the effect of having subsurface plankton blooms. Okay? So again, showing something very, very similar here on the left-hand side. Light intensity profiles and the nutrient profiles. So you can see one curve is light, the light curve, exponential decrease, and one is the nutrient curve. Okay? So what's shown here now is a mechanism of upwelling or entrainment. So what it means is you create an upward flux of higher nutrient concentrations. And if you do that, you bring the nutrients to different levels in the water column, you can produce a subsurface plankton bloom. Okay, illustrated here. It depends on how high you bring the nutrient-rich water. That determines of the production rate of phytoplankton. So if it's relatively low, you get a weak phytoplankton peak. Indeed, it all depends on the grazing or on the zooplankton activity in a region. Anyway, okay, but in principle, you get the strongest response if you bring the nutrient-rich water to the surface, okay? Because there the light intensity is at maximum. Okay. So you can measure these so-called subsurface plankton blooms. You don't see them with satellites. That's a little bit a problem, because you can't see them. I showed you the surface phytoplankton distribution just on a few slides ago, but you only see what happens at the surface. These ones you see below the surface. And here are some measurements just over my head. A vertical profile. So what this is actually called a Hofmüller diagram. So what's done here is you go with a boat and you measure a vertical profile of fluorescence. This is an indicator of phytoplankton bloom. Okay? So-called fluorescence. And then you repeat, say, half an hour later. Okay, and you repeat and repeat, and this is probably done daily. So this is a time series of vertical measurements over time. So the x-axis is time, and the vertical axis is depth, and the colors give you the concentrations. And here you can see a subsurface phytoplankton bloom. You can see over my head. This one at about 30-40 meters, very typical. Okay, these are subsurface plankton blooms. Yeah, how cool is that? It also supports marine food webs. Okay, not at a very, very high level, because you don't get that much production because it's below the surface, but still these exists in most oceans. Okay, these subsurface plankton blooms.